This is chapter 12, and we will start after the test with dimensional analysis. The nice thing about dimensional analysis is that it can reduce multiple step calculations into a single equation, and any medication calculation that you need to do can be worked with this particular process. The things that you need to remember is that all ratios entered must include the quantity, so you're going to have a number obviously, and then the unit of measure. So in other words, if it's milliliters or milligrams or micrograms, that will have to be measured or entered in as well. And entering in those units of measure will really help you to keep things straight and come up with the right label for your answer. A lot of times people get the right number in the end for their answer, but they have it labeled wrong, which of course is a wrong answer. Another key point is that the numerator in the starting ratio must be in the same measurement unit as the unit of measure being calculated. We'll see that as we go along. And the numerator of the starting ratio is never canceled. And you'll see that more clearly as we do it. So the first step is shown in this slide right here. And clinical ratio example. You've got a prescription. This is what you have ordered for 600 milligrams. What you have available is your 750 milligrams in 2.5 milliliters. So in a dimensional analysis equation, and I'm just going to start calling that dA, the unit of measure being calculated is written first. So in other words, what is it I am trying to figure out? I'm trying to figure out how many milliliters I'm going to have to give in order to deliver 600 milligrams. So that's what I write down first, is milliliters equals. The next step then is to match your numerator right here. That's a horrible arrow. With your unit of measure that is to be calculated. So in what we have available, we had 750 milligrams in 2.5 milliliters. So what we have to do here is have our numerator be milliliters, because that's what we started out with and that's what we're trying to end up with. So whatever is here must be in the numerator right here in the first clinical ratio that's entered. Okay, as we move on to the second step, then we have to, each successive ratio, the numerator right here, the label must match the denominator of the previous equation. So you can see that we've got a pattern going on here. We started with milliliters and our numerator had to be in milliliters. Then our denominator here was milligrams, so our next numerator has to be in milligrams. As you recall, 600 milligrams was what we needed to deliver. So our equation so far is milliliters equals 2.5 milliliters over 750 milligrams times 600 milligrams, and then we'll move on to the next slide. Only the unit of measure being calculated may remain in the equation after the denominator and numerator units were canceled. This will probably be on the next slide, but let's look at it. We started out with milliliters equals. That meant we had to have milliliters in our denominator, or in our numerator. And we started with what we had available. So we had 2.5, and in 2.5 milliliters, we had 750 milligrams. So now we know that because we've got milligrams in our denominator, this has to be milligrams, and our next number is going to be what we're trying to administer. So that was 600 milligrams. So we can see here now we're going to end up with milliliters because that's our unit of measure that we're trying to calculate. So look what we can do already. We can start canceling out milligrams because at the end we want to be left with milliliters. So let's write this out again. Milliliters equals, and we had 2.5 milliliters. Was equal to 750 milligrams times 600 milligrams over 1 equals, we canceled out our milligrams. We can reduce here by dropping our zeros. 2.5 times 600 divided by 750, we've reduced. Let me see here. 5 goes into 60 12 times. 5 goes into 75 15 times. And then I don't have my calculator here. Anyway, you end up with 2 over 1. And then that, of course, reduces down. You always want to reduce down to your lowest number and make sure that that is either a whole number or a decimal, and then round either to the 10th or to the 100th, whatever you're instructed to do or according to our rounding rules. So you end up with your answer being 2 milliliters because we've canceled out all of our milligrams. Here's another example. We've got an ordered dose of 50,000 units to be added to an IV solution, and what we have available is 10,000 units in 1.5 milliliters. So we're going to have to calculate how many milliliters do we need in order to give 50,000 units. So milliliters is what we are going to be looking for. So milliliters equals, we know what our available dose is. We know milliliters is going to have to go on top in our numerator. So it'll be 1.5 milliliters over 10,000 units times, now we know that this has to be the same unit of measure. So this will have to be units, and yes, I know I'm not writing that out. 50,000 is what we're looking for. That'll be over 1 equals, so now we can cancel out our units. We can cancel out zeros. And we end up with I believe we end up with 7.5. We will look on, and it will be, what do we have left? Milliliters. Okay, so we determined the unit of measure, which was our milliliters. We did that correctly. Then we set it up with our milliliter as in our numerator and our units of measure per those milliliters. Then these units, we know that in the next numerator has to be units. And when we do our calculations, we end up with 7.5 milliliters being our answer. Here's one with tablets. So let's look at the next slide and we will set that up. We know that what will have to go to the left of our equal sign is going to have to be our unit of measure that we are looking for, and that's in tablets this time. So we know what we have is in one tablet we have 0.5 milligrams. And we're trying to give, we know this has to be milligrams. This makes it really easy to know how to set it up because it's the same rule applies. Then you always know, and you're always doing it like this, then you're going to end up with the right answer. So we cancel out our milligrams, and we also need to get rid of our decimals, so that would make this 50, this 75, and then we know 5 goes into 50 10 times, whoops, and 5 goes into 75 15 times, and we end up with 15 over 10 equals 1.5 tablets, because tablets is what we have left. Now, to make sure that you've got the correct answer, you need to ask yourself some questions. Is the unit being calculated correctly identified to the left of the equation? In other words, you've got to make sure that you know what you're calculating. If you're looking for how many milliliters you're going to draw up or how many tablets you're going to give, that's what you start with on this side of the equal sign. Is the starting ratio entered so that the numerator here matches the unit of measure being calculated? So we know that the numerator must match the unit of measure being calculated. Alright, so we start out with, we know that these have to match. And then we know that these have to match in terms of labels. So is the unit of measure in each denominator matched in each successively entered numerator? So it's going to keep going. If we had more to the equation, like say we were maybe having to convert from micrograms to milligrams, which we could do with this equation, then the next one would again have to match. And we'll see some examples of that. Is only the unit of measure remaining after cancellation the same as the unit of measure being calculated? In other words, when we cross out all of those numerators and denominators that cancel each other out, we should end up with whatever we started with right here. The other thing you have to do to make sure that you've got the correct answer is, have your quantities been entered correctly? If you've entered 15 and it was supposed to be 1.5, then of course you're going to come out with the wrong answer. So you've got to make sure that your quantities have been entered correctly, and then is your math correct? So double check your math and make sure that it's correct. Okay, here is where that we will include in the equation a conversion ratio right into the dA equation. So if you're having to convert milligrams to micrograms or micrograms to milligrams, that can be incorporated into this dA equation. It's just another equation entered in, and we'll see that. You still do it the same way. We see here that we have a parenteral dose prescription for 275 milligrams. That's our ordered dose. What we have available is 0.5 grams per 2 milliliters. So we're still going to be looking for how many milliliters do we need in order to give 275 milligrams. Since it comes in grams, we're going to have to do a step that converts our grams to milligrams. So we do the same thing to the left of our equal sign. We're going to start with our unit of measure, which is milliliters. So that means we know that we'll have to have in our numerator, in our first ratio, milliliters. And that's what we're starting with, is 2 milliliters. There's 0.5 grams. Now here's where we do our conversion. If grams is here, we know that grams has to be in the next numerator. So 1 gram is equal to 1,000 milligrams. And see, now we're ready to put in our ordered dose, and it fits right here because we're putting in our next numerator to match this denominator. So we put our 275 milligrams over 1, and then we do our calculation. So you can see here the pattern. It just continues. Milliliters, grams, milligrams. And these can all be canceled out. And you're left with milliliters for your answer, and you've done your conversion in the equation. And then this last slide just shows your the actual math, and you end up with an answer of 1.1 milliliters. Do the work in your book. That's dimensional analysis, pretty simple. And you've got lots of practice problems in your book, and hope this helps you so you can go back and look at it again if it's a little confusing to you.